Every second of the day, the world is changing. Natural disasters, geopolitical shifts, rapidly changing environmental conditions. These challenges make it critical to observe changes in real time, understand what those observations mean, and quickly act on them. LEO, or low Earth orbit satellites, are emerging as a new generation of space infrastructure, helping to monitor our planet and deliver actionable insights wherever they are needed. So, why are LEO satellites becoming essential infrastructure? Unlike traditional satellites that operate tens of thousands of kilometers above Earth, LEO satellites orbit at altitudes lower than 1,000 kilometers. Because they are much closer to Earth, they can capture higher resolution imagery and transmit data much faster than standard geostationary orbit satellites. The shorter signal distance also produces stronger return signals, enabling more accurate observations when time-sensitive decisions matter most. But location alone is not what makes modern LEO satellites so powerful. Many of today's observation satellites, including LEO satellites, use synthetic aperture radar, known as SAR or SAR. SAR satellites transmit radar signals and analyze their reflections from Earth's surface, allowing them to capture imagery regardless of weather conditions, cloud cover, smoke, or darkness. As a result, SAR satellites can provide reliable, around-the-clock monitoring of maritime surveillance, infrastructure management, disaster response, and environmental observation. But effective observation requires far more than satellites alone. From launch systems and satellite technology to communications networks and AI-powered analytics, delivering meaningful insights depends on every link in the space value chain working together. Then, how is Hanwha contributing to the next generation of essential space infrastructure? Hanwha is building an integrated space ecosystem that spans this entire value chain. In 2023, the company launched South Korea's first privately developed SAR satellite, capable of delivering 1-meter-class resolution imagery. It can observe infrastructure such as bridges, airports, roads, and waterways while providing reliable monitoring day and night. Then, in 2025, Hanwha completed the Jeju Space Center, which is expected to serve as a base for the growing space economy. The facility can assemble and test up to 100 satellites per year, strengthening Korea's satellite production capabilities and supporting the expansion of future satellite constellations. Hanwha is advancing satellite communications as well, through plans to deploy hundreds to thousands of satellites in LEO and very low Earth orbit, otherwise known as VLEO. Hanwha aims to establish the world's first VLEO satellite constellation, operating even closer to Earth than conventional LEO satellites at an altitude below 400 kilometers. These systems can provide more precise Earth observation with 10-centimeter ultra-high resolution imagery. They can also support smarter logistics by helping to optimize shipping routes while reducing transit times, operating costs, and carbon emissions. As the demand for real-time intelligence and global connectivity continues to grow, space infrastructure is becoming increasingly important to everyday life on Earth. In connecting observation, communication, and intelligence, Hanwha is helping shape the new space era, while creating the infrastructure needed to support a more connected, resilient future.